Yes.
Okay, cool. So welcome. We're here to talk about how you can get into an AI role at a top company like Apple, Google, or Facebook, and the right resources to make it happen. Midway through the presentation and at the very end, I'll take questions. So without further ado, let's get started. So this quote from Andrew Ings aptly summarizes what AI is all about. A lot of you probably know Professor Andrew from Coursera, owing to the extremely popular ML course online. Artificial intelligence already powers many of our interactions today. When you ask, Siri or Google Assistant for directions, peruse Netflix's recommendations, or get a fraud alert from your bank, all of these interactions are essentially led by computer systems that are using large amounts of data to predict your needs. Just like electricity has changed how the world operated, AI is poised to have a very similar impact. Despite all the hype and excitement about AI is still yet to ripen up as a field. It's still extremely limited today relative to what human intelligence is, which is where you step in as an agent of change. Now let's dig into how you can craft a game plan to make this possible. So before we go too deep into what you can do with AI, let's talk about what I do first. And to give you a rough idea of my academic and industry choices, I started my journey 12 years ago at TSEC, graduated from the Department of Electronics and Telecom, went on to the University of Wisconsin-Madison for grad studies, was at NVIDIA and Qualcomm shortly after, and now back to school at Stanford. I also work at Apple full-time for the first half of my day. At TSEC, I was fortunate to be able to explore research and understand what it's all about, thanks to the tutelage of Mani Roja ma'am. At Madison, I explored the field of computer architecture, going to its rich history, being a top place to learn about the architecture that goes behind making the world's best CPUs and GPUs. At Stanford, I am now exploring AI part-time. While at Apple, I work on making your Macs run as fast as they can, and more on that in a bit. So at Apple, every portable and desktop Mac that ships out of the company needs a green signal from our team from a performance perspective to go out the door in the hands of the public. As such, my job as an engineering lead at Apple is to ensure we live up to those high standards that the company set. Apple is known for their magical products, and this aspect, this magic, as we like to call it, is a product of relentless hard work and innovation. Now to get there, we deploy a strategy that is twofold. Using AI models, we estimate performance for future Macs years in advance. And later on, when we make prototypes, if something isn't quite meeting our expectations, we root cause issues to any point in the hardware software stack and get them fixed. Note that as of last month, actually, Apple announced that we are now moving to our own hardware chips within Macs, compared to the earlier ones that we had from Intel. And this is a project that I personally worked on for the past 3 years or so. And what this means for the end user is that Apple more or less now has total control over all the layers, right from the OS to the driver to the chips that run everything. So it's possible to get a wide range of changes or improvement and shoot for the stars, if you will, to extract the max performance you can from our product offerings, which is what sets them apart. Now, let's shift gears to why we are here today. I'm here to talk about why AI is important and how you can utilize your time during your undergrad to succeed in academia and potentially with a future job role in the industry. For me, my undergrad was a critical time to get my basics right, probably the most crucial time out of all my academic stints. Thus, my recommendation to you is to explore new fields like AI to get a head start as early as possible. Now, AI adoption is definitely onto an upward trend, but is yet to see its largest peak in the curve. IT, web search, advertising, these are some of the fields that are already being powered by AI behind the scenes. So AI, decides, whether we get approved for a bank loan, for example. It helps us order an Uber or a pizza. But there are still tons of areas that are ripe for AI impact: healthcare, self-driving cars, and security. Just a few examples. Now, there are three main problems, though. There's the scarcity of data, algorithms that extend to a wide range of cases and conditions rather than just some corner cases here and there, and lastly, rich human talent. Now, let's talk about each of these three cases one by one. For AI to be meaningful, companies need to feed their algorithms vast amount of data, which isn't always readily available. Some large companies actually launch products just to gather data and then later monetize it through a different product. Coming to the point of building solid algorithms, artificial general intelligence, AGI, is actually a very important concept that everyone's after today, at least in research. It basically encompasses algorithms that extend to multiple tasks which a human being can easily carry out. Now, companies are kind of engaging in a talent war for smart employees as well. In fact, the most scarce resource out of data, algorithms, and talent is actually talent, because AI needs to be customized for every business context. You can't just download an open source package, apply it to your problem, and expect it to work reasonably well to industry grade standards with a very high success rate. So the key takeaway point here is that while AI has a potential to transform our day-to-day lives, and it's already doing so to some extent, there's still a lot of undiscovered potential on the table yet to be explored. So like I've mentioned on this slide here, there's new ideas in computer vision and natural language that are changing the field with every passing year in AI. So how do you go about creating a dent in this field? So what I do is I strategize your planning at the top level using these three simple steps that I've laid out on this slide. I'd take online courses, and you have YouTube at your disposal. Secondly, I would build projects, use GitHub for reference. And lastly, make it a habit to read some world-recognized literature on AI. Now, let's dive into some resources that I've crafted for you to help carry out these steps. Now, the flowchart here basically shows how I went about building my knowledge base in AI and the plan I followed to set up my footprint in the field. So my recommendation here is to start with a very basic online Coursera course, which isn't typically extremely demanding, and basically Coursera is great to delve into the what and the how of things. Once you've done that, then I would say the next step is to build up some solid knowledge by enrolling into the more in-depth courses from Stanford, for example, which answer more of the why behind every concept. Now, while I attend courses as much as I can in person, in your case, nothing should stop you from getting access to content from each, if not most of these courses, thanks to YouTube. Think of the concepts in each of these courses as tools in your toolbox. Learn how each tool works at a fundamental level, get it right by first principles, and then get an idea of what each tool is good for. Now, equally importantly, I'd say understand what it's also not good for. Okay, so let's dive a little deeper into this flowchart now. Obviously, you don't need all of these courses to set up your camp in the field. Some courses are definitely more advanced than the others, and I treat them as optional. So I've labeled the the advanced ones here, the basic ones, and the industry grade ones, which are essential to, to get a job in the field or to do something great and influential in the field. The advanced courses build your intuitions from both a top-down and a bottom-up perspective, but they are definitely much more demanding and challenging. Also, the other point I want to make here is that the Coursera deep learning specialization is actually a very great, set of courses to get started before you get into the Stanford offerings, which are available on YouTube. Like I mentioned, the Stanford courses are several times much more intensive than the Coursera ones. I think we can pause here and take some questions. I think that it's a good time, and then we can also take questions towards the end. But yeah, do we want to open up the room for some questions? Unmute people. Are people unmuted or?
No, I think anyone having any questions now? You want to ask Aman now?
And we'll obviously be taking questions later as well.
Okay.
But that's a good point.
Hello?
Yeah.
Who want to ask? Okay, Aman, you continue. We'll see later.
Okay, yeah. And we can, definitely take questions later. Okay, cool. Okay, so the other thing is the series of courses that we just discussed are definitely time consuming and need patience, a good grip on fundamentals and whatnot. Now, here's something to make this easier for you. After having gone through a plethora of courses at Stanford, particularly also MIT, Coursera, and elsewhere, I've been working on putting together my notes and assignments from each of these courses on my AI journal at aman.ai. And I just started actually doing this when the lockdown began a couple of months ago. This is a vast effort that will take several months to complete, but a lot of the work has been put in already. There's good content for you to get started. Now, the goal behind doing this is to basically explain every single concept that I've learned as part of these courses in simple terms, with as many additional resources as possible for people who want to walk the extra mile. So let's sample the CS231N course at Stanford, which is actually a very in-depth course covering convolutional neural nets. So this is basically when you basically tap on or click on the
Aman,
box.
Aman, yes. Sorry to disturb you. I think we can't see very clearly. Can you zoom it little?
This is actually a screenshot of the website. I don't think zooming in would be possible here. But the idea is to basically give people a pointer to the website so they can explore for themselves. There isn't much in the text that I'm expecting people to go through. I'll definitely do a voiceover of whatever I want to convey over to people. So I think it should be fine overall. Yeah. Okay. So this is an index of everything that's covered in the course. And I know the text might not be as visible, but the point is that the course covers 15 to 20 lectures, 1 hour each. If you look up the course on YouTube, lectures are again, openly available. Each lecture is very dense. It covers one topic in utmost detail. In fact, all around the globe, this is touted as the most in-depth AI course ever, most in-depth deep learning course ever. So this is basically the index of the course. The details aren't very important, but the point is, I've got a sample topic here, which basically shows. It talks about the one of the bits that I love the most about convolutional nets. It basically shows what a convolutional net is actually looking for under the hood when you train it on a data set. What does it learn at those various layers? So this is basically a sample of what I've written. Each of these links here in the index for this course in particular like I said, are extremely detailed. There's a lot they cover in just an hour. But I have tried to, jot it all down, with images and with references, with papers if people want to go deeper in any topic. So I put it all together, and it's an ongoing task. A lot of it, in fact, isn't there yet, but there's a lot of links that are already up and running. And over the next couple of months, I think I should be able to put everything on. So this is my attempt at making, my learnings easily available. Now, the other thing I've done is I have also put together a collection of my handpicked resources in terms of blogs or websites on AI/ML that I regularly track to get the latest scoop in the field. And it's available at aman.ai/read. Now, another resource that's very interesting is basically a friend of mine has also created this offering called the state of the art in AI, where you can, find not just papers, but also code bases for ideas that are getting published as we speak. So all the latest stuff is there to help you get started. And there's about 2,000 or so tasks that AI models are currently, able to, attend to and deliver some great results on. So it's sorted and organized by categories. And a lot of the great work has already been done for you. So you can play around, figure out a nice problem, and have code to inspect and figure out what how the problem is being handled, and then maybe extend on it. So that's it. And now here's some actionable ideas that I put together for you guys. The possibilities with AI are endless, right? 2,000 or so tasks that we currently can handle just with the concepts of AI isn't something small, but we still feel that we're only scratching the surface, if you will. Here I've got a set of steps to make your mark in the field. First thing is you find an application area. You understand the state of the art in the field, and you can use the resources that I've pointed to earlier to get there. And finally, reinvent the area just a little bit by coming up with ideas to improve that application area you chose and reimagine it. Another point I'd like to make is that your undergrad branch shouldn't be holding you back to build these skills and eventually get into top companies like Apple, Google, or Facebook. For example, most of these courses that I mentioned earlier are available online freely or openly. Lastly, I think we're at the tail end of our talk today. You can feel free to check out my website to get access to all the resources that we discussed today to get started. And if you have any questions, you can also email me. Lastly, thank you. And with that, we can take some questions now.
Hello, students. You want to ask any questions to Aman? Hello? No one is having any questions. It's like two cases. Either you have understood everything or you didn't understand anything.
You definitely have my email, to ask questions today, tomorrow, next month, next year. I'm not going anywhere, but yeah, if anyone has any thoughts or ideas, questions, feel free to chime in.
But I think Aman, you completed very fast. But let me anyway, thanks. But students, see what we want to take from this webinar is, so your branch doesn't matter. You have to do some extra mile when you want to go into AI companies. So now we have Coursera options freely available for us. And registration date is extended till September 30th. So you have seen how he made himself ready for means artificial intelligence area. So any branch you belong, EXTC, biomedical, or chemical, it doesn't matter. Only you have to take an extra step so that how you can get into AI industry. See, machine learning, the basic is EXTC. So I think you should not worry about your branches. You have to utilize what you are studying, and especially you have to utilize this lockdown time so that you can get into some another area. And so I think it's a correct time you should start preparing these courses. And since it is available free also, I think you can develop proficiency in this area so that you are not worried about your job and all. And you can get into good companies or your dream companies. So please do the extra mile, walk extra mile so that you can get into these companies. If anyone, so there is a question over here from some, how to start with the software of AI. Aman, for you,
Sure.
question is how to start with the software of AI.
Right. So the good part about, especially the courses, the basic courses that I've highlighted here, especially Coursera, is that they do not expect you to know a lot, and especially us as engineers who are already deep into the field, rather than people from outside of technology, right? Because AI, the field is so open that if you're a doctor or if you are a psychology major, let alone an engineer, you can equally contribute to AI, the field of AI, or be a part of AI. It's open to all. Now we are engineers at the end of the day. Our basic linear algebra or calculus or even basic coding, we've got it. Now the things that you fear about, or if this is your concern that hey, I'm not too good at this stuff, especially getting some basic coding skills. Basic courses like Coursera help you get there. In fact, they will take you from the basics to at least a working knowledge of the field, which is what the expectation behind a basic course is. And like I said earlier, for the more in-depth stuff, you got options. But don't worry about the coding part. You definitely don't need a lot of the data structures and algorithms, if you will, that other fields focus on. It's good to know those things. They are very helpful, but it's not a a stringent requirement at all for even the more advanced concepts in AI/ML. So I don't think that should be a big concern.
I also want to add, I think before starting, you should have Python knowledge, because even I was like having tension whether I'll be able to go into these courses or not. So I started with Python, programming for everybody, 1 or 2, and then I completed one after other, and today I have the certificate deep learning specialization. So if I can do in this age, I think students, you can do it. So start it and get the specialization certificate, which is free of cost. Okay. Aman, next question. How compatible is our math in EXTC to machine learning? Or which part in maths we should focus on more?
Yes. So I think a bit of this was covered already in my answer to the last question. So you need basics of linear algebra. You need some calculus. I'd say, and some statistics, very minor though. I don't think there's not much that's needed, honestly. And the good part about AI is you can build as you go. Get started with the base. You should know how to set up an equation, how to calculate derivatives and such. And that should be good enough. Now the other part is these concepts are needed to understand things from bottom to top. But the thing is, there's always libraries available and stuff that abstract out all those details. Although the recommendation isn't definitely to ignore the math behind the details, but basic linear algebra and some calculus definitely can get you there. You don't need much beyond that. Which, as EXTC engineers, I think we have much more than that already under our belt. So yeah, that I wouldn't worry about that at
all. Next question. Does Apple also hire people from the field of MEM? from the specialization in project management or a lead analyst?
Yes, we do hire people from a wide variety of backgrounds, and MEM project management is also a big part of the products we deliver. Yeah, we're always looking for great minds um, that are interested in exploring Apple.
Okay, next question. Is there any link between artificial intelligence and data scientist?
There is. So AI involves much more of the model building and figuring out how to go from your input to the output, which is the model in between, right? The model is a function approximator that's trying to map how you can go from your input over to the output you expect. Now, the thing is, with a data scientist, you're mostly dealing with the input. You're trying to figure out if your data is well conditioned, if your data meets certain criteria, and if in production pipelines in the industry or in a real job, where you're actually using AI to carry out something in an app or a website, if you consider data, is probably coming in, live, right? Users are, looking at content online, they're reading stuff. So all of that data is being fed into a live system, say Facebook, for example, right? A data scientist's job is basically to figure out how to get that data in a format that can, interface well with the model, which is the next step in the pipeline, and get it right in a live system, which has its own set of challenges. AI, on the other hand, like I mentioned, is more the middle ground, which is getting the modeling part right to go from your inputs to your output.
Next question. Can you suggest some projects after getting some basic knowledge?
Sure. Yeah, I can. In fact, I would recommend looking at. You guys can still see my screen, right? Is my screen visible?
No, but we can't read anything from the screen.
Yeah. Don't worry about it. The point behind the link here. The link hopefully is readable.
Yeah, link is readable.
Yeah. So the point behind the link here is that, like I said, AI covers too many fields right now. If you like processing images or video, the visual part of things, or if you like making, if you like figuring out, for example, how Google gets its search queries right all the time, right? And not just that, right? And I mean, there's a funny saying that if you can't find something on page 1 of Google search results, it's probably not worth going to the second page, because there are algorithms behind the scenes that are trying to make sure they rank their results as best as possible. So they're trying to estimate what you want. They are trying to use their infrastructure to do that real time in a matter of a couple of couple to 100 milliseconds. So it's that granularity. So if you like that part, that's natural language, right? So there's computer vision and natural language. Those are the two big domains in AI, if you will, right? So what I would recommend is go to this website. After, obviously, like you said, you build some basic skills and try to explore what problem within these two fields would you like to focus on and contribute to. There are thousands of problems, and each is unique in its own way. Like I mentioned a couple here, right? You can, the screenshot basically talks about a couple, right? If you want to basically give your model an image and try to figure out what's inside the image, can the model tell you back in natural language, which we human beings communicate with, what it sees inside the image? I think that's a big landmark, right? If we can make machines do that, essentially we are one step closer to making, robots or, machines around us be able to see and figure out what they're seeing, right? Looking at things with a basic camera on, say, a Raspberry Pi is one thing, but getting those images into a model and making the machine figure out what it's seeing, that's another. So there's a lot of tasks. and to each their own, right? Like I said, there's so many choices. If you go through this link, you will have tons of options, tons of choices. Each of these links in turn has tons of papers that you can read on. I would start with a review paper, for example. I would start with a review paper for any of these domains and see what you can do in that field, come up with ideas and explore it. But like I said, the world's your oyster. There's a lot of options. This is a very big milestone in not just technology, but several domains. And like I mentioned earlier, it's like electricity. It's going to impact a lot of things around you. And it's already doing it. So yeah.
Next question from Matthew, sir. What are the challenge as an AI expert you are facing? When you expect an AI expert a must need for industries in India?
First of all, hi Matthew, sir. Secondly, could you repeat the question? I think I didn't get the latter part.
What are the challenges as an AI expert you are facing? This is first part.
Sure.
Second part, when you expect an AI expert a must need for industries in India. India, when you need that opportunity will come for an AI expert.
Sure. Okay, first part. So the thing is, as far as the difficulties in the field is concerned, there are plenty, which is what us as budding researchers or technology folks who are trying to understand what this field is about. Our target should be figuring out the cases that current AI models aren't able to get to, and there's a lot of cases, irrespective of what you read in the paper saying machines are going to take over the world and terminate this, the D-Day is here. That's not how it works. Maybe sometime, but not right now. There's too many limitations now. Our models are pretty good at like I mentioned earlier, going from an input to an output, figuring out what it takes to make this transition, to make this jump. Beyond that, if you try to say train your model on a particular data set, say that detects cancer in maybe a particular organ of the body, for example, and if you just try to simply use another data set that looks at MRI images or CT scans, for example, and you're trying to detect cancer in another part or organ of the body, it does not translate as easily. The thing is, the models get too accustomed or overfitted to a particular task, even though there are a lot of concepts available to deal with these things. But it's not as easy as training someone. Like if you have a doctor in front of you and you train them how to read these X-ray images or to detect these kind of abnormalities, they're able to make general observations. But not so much with models. They are pretty limited in that sense. They can carry out one particular task very well, but for them to generalize to a wide range of options or other tasks, not as easy. Which is basically, so people in the field call this artificial general intelligence, AGI, which is what everyone is actually after. Because and I see a lot of that in the recent papers, and the trend in the top conferences in AI is basically trying to figure out ways to make machines generally more intelligent rather than intelligent in a very constrained area, which is what current models are great at. So that's basically the answer to your first question. Now the second question. So the thing is, as far as India is concerned, we already have a lot going for us. That is the reality, actually. Now, if you look at all of these companies, the local Silicon Valley that we have in Bangalore or Hyderabad as well, there are all of the companies here, basically more or less the top companies are branches there. And not just the top companies. There's also relatively less known companies, but companies that are doing stellar in the field. A lot of these companies are dependent on AI right now, because essentially all of these companies just need some great talent. right? Just like the way China is able to have all those manufacturing lines and churn product after product, we do have some great talent in our country. And people obviously recognize that. And they've set up base in India, in Bombay as well, in BKC, in some cases in Bangalore, Hyderabad, like I mentioned, and there's a lot of opportunities. I think India is doing very well, scaling up to getting all the talent ready, and our engineers, I think, are well positioned. You can do a couple of these courses. You don't need to do all the stuff that I discussed, but even if you start venturing with a couple of courses, your skills will be very valuable.
Thank you, Aman. Thank you very much.
Sir Matthew, sir.
Next question, very interesting one. Is the Coursera certificates really useful, or we can go with YouTube?
Yeah. So the way it works is step into the shoes of a company that's trying to hire you, right? Once you are able to get to a call where you have a decent resume and the company is interested in talking to you or hiring you, you go on site or you talk to those people. Now the thing is, for a company, if you step into the shoes of a recruiter who's representing the company, at the end of the day, they want to make sure that you have the skills in place to make good things happen for them. So for them, your certificates are definitely valuable. But if you can, get maybe certificates from Coursera and do online YouTube courses from, say, Stanford, from the Stanford YouTube channels, and there's MIT as well. There's tons of content available, honestly, not just Stanford and MIT. But if you can, gather all the skills from these courses, make notes like the way I'm doing, and, just get yourself involved in the field, build nice fundamentals, and understand those concepts. That's what they need, because ultimately they need you to, create these models for them, know these fundas, do the right thing, and choose the right kind of model. And these skills are very easily acquired through the content we have available online. Again, totally free. To answer your question, certificates are good to have. They are valuable. If I have the option of getting a certificate, I do. If there's no option, no worries. It doesn't change much, honestly. Some basic, a degree is definitely required, just to show that, you are worth your metal, but which is what we already have, right? Our college, our university offers a great setup there. Mumbai University is actually pretty known. It's got a nice alumni base, and that helps. But beyond that, you can use YouTube. It's not a big problem, and use Coursera for the basic courses, which can get you certificates easily. Okay, next question.
Okay, next question. Since AI is very popular now, will there always be an equal availability job opportunities?
Right. So the thing is, AI is indeed very popular, and it's been popular for a couple of years. Typically, what happens is, for any field to mature, it takes time. And I think we are very early in the stage. So this is the best time for you to develop some skills and understand the field. In fact, the portion of the curve, the growth curve that we are in right now, the slope has only been increasing over time. It has not plateaued, and definitely not. It hasn't been declining. So yeah. There should be no issues right now, or even in the near foreseeable future, for you guys who are already in a bachelor's program right now. There should be no issues getting into any role.
Next question. What kind of projects did you make so that you got working in Apple?
That's a tough one. So I went through a master's program, after my bachelor's at ESEC, which gave me a very solid foundation, my bachelor's, right? And then I kind of topped it up with a master's from a good university, and basically try to get my ideas and fundamentals right in whatever I did. I did a lot of different things at a lot of different companies during my masters and after my masters before joining Apple. In fact, I like to do something different at every place I go to. Otherwise, it just gets too mundane. So yeah, diversity is pretty good. And as far as projects in particular, if you're interested, you can read more online on my website or on my GitHub. If you want to look at code, you want to look at my projects, I've got a lot of stuff on my profiles there. Yeah, that should have.
Hey, Aman.
Yeah.
Hi, this is Shretan Badia, and I hope you're doing good.
Yeah, hope so too. Yeah.
So actually, I just got accepted at Arizona State University for data science, and I'm really eager to expand my horizons with ML and AI as well.
Okay.
Okay, so I really wanted to ask you during your master's plan. So were you more into learning stuff, or you were getting more of internships to get hands-job experience regarding it? So what was your approach regarding it?
So the thing about a master's program is, I think master's programs are pretty geared up to get you some great practical knowledge, so you can do pretty well in the industry. Now, at the same time, you've got internships to actually explore, how your skills are applicable and relevant to the industry. So what my focus was basically to try and intern in as many different places as I can, because one thing that and this will apply to a lot of you who are trying to basically get on to the next thing after your bachelor's. What happens is basically an internship is a very nice way to sample different companies and different job profiles without a lot of trouble. And what I mean by trouble is, once you get out of your degree and get a job, most people kind of tend to stick to their jobs for several years. There's very few people who like to change jobs every couple of years, but then the norm is basically people stick to something, in some cases for their entire careers. That's pretty normal. Compare that to an internship where you can go to a place, sample it, and let them sample you and your skills for a couple of months, and then you go back to your university and maybe do another intern or something, and you can then go to another place and then sample a very different location or a very different job profile or a very different company culture. So I think an internship that way is pretty good to try out various different domains, build skills in various different domains. So that was my focus. I wanted to go to at least a couple of places rather than doing one intern or maybe no intern. And at the same time, I was also working on my thesis during my master's, which lent out pretty well, because I could do my thesis work while I was working. So I could do thesis work in the night and work in the day in the office. So it all panned out very well. That was my strategy around how I went about doing internships and also thesis, and how I picked my very different internships at different places.
Okay, thank you so much regarding it. Yes, definitely.
Yeah,
and one more thing. So
sure.
I actually saw the Mac OS 14 launch. So is the new chip going to be as reliable as the butterfly keyboard? I'm just kidding with you.
Yeah. So the new chip is something that the world has not that particular chip, but the world has kind of already sampled it. Your iPhones and your iPads already run our chips. So and we at this point in time, we are world leaders in not just the iPhone compared to the Android as far as the hardware performance is concerned, but also the iPad is pretty competitive. So we, over the past 10 years or so, we've definitely been all hands on deck trying to make sure we churn out the best silicon possible. So expect something nice, yeah, and reliable.
Okay. Aman, there is
thank you so much.
Okay. Aman, question from Rajput sir. Sir, you can ask the question. Rajput sir, you can ask the question.
Hello.
Yes, Adput sir. Hi.
How are you?
Good, good. How are you?
I'm going fine, fine, fine. Actually, see, I just wanted to ask that in order to make our EXTT students AI suitable, which are the subjects we need to include in the final year or lower semesters? And secondly, which are the programming language or technologies in which they can be trained? These two questions I wanted to ask you.
Sure, sure, sure. Okay, so coming to your first question, are you, some follow-up questions for you. Are you talking about special courses, maybe evening courses or something extra on the side? Or are you talking
Some
about
kind of
some courses that
either
already
in,
exist?
no, now the syllabus is under revision, so
Yeah.
we can include these courses as elective subjects. Okay. And plus, what are the add-on courses which we can offer for current batch?
Got it.
Because
Got it.
the revision will take time. Okay. So till that
Right.
time, we want to train them so that those who are interested in pursuing AI, they can take this training.
Got it. Yeah. So what I would recommend is, as far as the math behind things is concerned, I think we already covered that. But the idea is to have topics, basic topics in math that cover linear algebra, probability, some statistics, and derivatives. These are the four mathematical areas, which, like I said, we already have much more than that actually. Transforms and whatnot, which are actually applicable in AI. So that part is already there, but that needs to be there. So we definitely want to retain that. Now, as far as the coding part is concerned, introducing some courses in basic Python would be very beneficial. What I'm seeing right now is basically the trend is, and this has been the case for the past several years at this point, the trend is to move out of prototyping languages like MATLAB. And no disrespect for MATLAB, I've used it, for several years, and the free alternative Octave as well. But the idea is that the industry, or even in academia, Python is free, right? Even the academia, the people are moving over to Python just because, and Mani Roja ma'am, I think, highlighted this as well. Python has some of the best libraries right now to not just build AI models, but to do a lot of things under the sun. Right from visualizing data, carrying out that math that I spoke about, building these AI models for sure, doing data scientist kind of work where you're pre-processing data and getting it right. It's got libraries for a lot of stuff. Python is also my preferred programming language, or scripting language, if you will. So I think these areas are what you need. Now, obviously, if you're looking to introduce some AI specific courses, then the content that's there in the basic Coursera ML course, which which covers actually the mathematical concepts and also some AI concepts. Though some concepts from those courses might be great to package as a course if we are open to building something new. In fact, AI not only has application in the areas that I spoke about, computer vision, natural language, even medicine. It also has application in electronics and circuits, where you can make it solve circuits and generate circuits. I've seen a lot of people come up with these ideas where they feed a model some idea of what they want. They want their output to look like this if the input is such, right? And that's basically what a circuit is. It transforms a particular input to some output that you desire, right? So it figures out the middle part, which is the actual circuit. So that is also possible with AI. So yeah, does that answer your question?
Thank you.
Next question from Dr. Darshan Ingle. Darshan, can you ask your question? Darshan?
Roja ma'am, he's not in the meeting.
Okay. Okay, but he posted the question.
Yes, ma'am, he posted.
Or probably dropped out.
Okay. Next question. I want to be in the satellite transmission and data post-processing. So that what approach do I use to incorporate AI into it?
Okay, so it depends on your data. There is no black and white answer to your question. It depends on how the data looks. The way you figure out what concept within AI would lend best to your use case is by first starting with your data. If your data is basically, a string of numbers, or if it's, textual content, then basically we've got models for that. Now if your data is basically, a visual form where you're sampling, images from a camera, for example, you've got different kinds of models for, to handle that kind of stuff. So it totally depends on your input. Now, the good part about AI is at this time, I think we've been able to handle a lot of the various forms of, what an input can be, which means given, a particular data or input data, there's always ways to structure it and apply an algorithm that is well versed to handle your data. So there's research in all kinds of fields right now. And like I said, this website that I've highlighted here is a great way to explore, what research is there in the field after you've gone through the fundamentals. By the way, the notes on my website not only cover the visual parts where you're using an AI model to figure out an image or a video. We've also, I've gone over multiple courses where you're, working on text or, a pattern of numbers coming in as input. So there's courses for everything. And I've covered them on my website as well.
Next question. Hi, Aman. Myself being an EHTC student, I wanted to ask, can you give us bit background of your engineering days? What kind of courses you did? What should we learn as a EHTC student?
Right. So I think we went over a couple of ideas here in the other questions. The mathematical fundamentals are definitely helpful. You can always write code that doesn't need the math behind stuff. That is actually what most people do, because you don't need to get into those, the nitty-gritties and the intricate details, especially when you're building something, substantial, something big, right? That's totally fine. But the thing is, when you have to debug something, when you have to make something work, figure out what's holding it back, why is it not functional under certain scenarios, you need to be able to understand what's happening behind the scenes. So the math definitely helps. And like I mentioned, some calculus, some statistics, some linear algebra, some probability-based theorem, conditional probability. Those things, those things are basically what would serve as good fundamental building blocks, after which you can go through one of these free courses from Coursera, and that should get you a good start. But yeah, our EXTC syllabus that way covers a lot of, mathematical fundamentals, much beyond what I discussed, right? So I think, like I said, we are very well positioned. Our syllabus is such that it covers a lot of stuff. And I think that's a good idea, because you never know what you'll use. And like, for example, when I was doing my undergrad at TSEC in EXTC, I didn't know I would be using these ideas, in the future. And right now they're my bread and butter. So yeah, that's the answer.
Okay. One student again and again sending the message, what were you tested on for your interview for the position in Apple? How was the interview like?
Sure. So this is a difficult question, but a good one. So the thing is, at a company like Apple, what happens is they make you go through a rigorous process spanning multiple days, where you have one round of interviews on the first day, then the other round of interviews on the next day. Usually 2 days is good enough, but note that it goes from morning 9 a.m. types to end of at the end of the day up until 5 or 6 every day, both days. So what they usually focus on, to answer your question, is basically, anything from it depends on the job role. It goes from anything from the fundamentals to how you can, whether you can think out of the box, whether you can present data well, whether you can convey a message, very well. You can articulate things or not. Whether in some cases, if it's a coding job, obviously they're going to make you code. Yeah, it totally depends on the job, but it's a rigorous process in any of these top companies. Every company basically has the same motive, right? If they are investing in you, they want to make sure they're making the right call. Typically, these companies have a lot of applicants per position, and 30-40 applicants for a single position aren't very uncommon, which means they will go through several months of interviews to figure out the right person, and they will keep people on the hold, because they know that people want to be part of these companies, and a lot of the companies do that, not just Apple. But ultimately, first day they check you on your technical concepts, whatever you've learned in your bachelor's, your master's, if you've done a master's, or a PhD, and the next day they will check maybe some soft skills where the executives and leadership folks, right from directors to vice presidents or even SVPs in some cases. If it's a high-profile hire, you will be talking to the CEO in some cases, or at least the SVP, and they are going to ask you, in most cases, very basic questions, and expect some great answers. Yeah, so it's a very broad question. The particular questions they asked me don't matter as much, but the idea is to be able to get all the fundamentals right. And by the way, the other thing I want to tell people, and I think this is one key takeaway, a big key takeaway from our talk today, and this applies not just to Apple, to all of the big companies. They don't want you to, or rather, they don't expect you to get everything right. They want to check your thought process, right? No one, well, there are obviously exceptional people, and but the thing is, they want to see if you have it in you to figure out how to, create the pathway required to get to the solution of a particular problem. Whether you're able to get it right then on the spot is not what they're looking for. But if you can think right, if you have the right thought process, they value that. I think we need to mute someone, but my point is that there's a lot of things that they test on, but make sure your fundamentals are spick and span. And have skills in a broad range of areas. That definitely helps, including communication. That's a very underrated skill, but it works wonders. Okay, next.
How advanced DSP has a role in artificial intelligence?
Sure. So the thing is, the transforms and these more advanced concepts that we learn in signal processing are actually applied in some algorithms within AI. For example, the Laplace transform that we've studied, there's Fourier transform, and there's a bunch of other things that we study. A lot of these do apply to some specific instances. Now, also not just the models themselves, the input data that you acquire. Sometimes, as part of, like we discussed earlier, as a data scientist role, you have to condition the data in such a way that the model is able to operate on it as best as it can. And it's a trial and error experimental process, although there's obviously science behind it. But part of conditioning your data or pre-processing your data is also making sure that maybe in some cases you'll have to apply a transform on the data to represent it, say, from frequency to time domain or the other way around. And that makes the model run better. That happens. So that is also part of the journey here. Figuring out how to best represent your data. Maybe you have to alter the distribution within your data, where it's a Gaussian distribution, but you have to make sure that the it's 0 centered, the mean 0 and the variance is 1. So the spread of the data is pretty standard. Models like that. And obviously there's a research that, people have been, looking into as far as these areas are concerned, and papers get published every now and then saying, oh, if you alter your data in such a fashion, apply these kind of transforms or alter the data distribution a bit and send it to your model, it will work, better. It'll perform better. So you need to know these concepts. Otherwise, getting the basics is not difficult, but getting the, like they say, right, the first 80% is usually pretty easy. Beyond that is where you have to figure out how to get the last 20%, which is, while people think that there should be a linear relationship, but in some cases it doesn't work that way. And this is one of those cases where if you want to improve your model, you need to have, the wildest of ideas and the most breadth of knowledge to be able to eke that 2%, extra 2% in accuracy, which is what a lot of the people, the smart people, are doing at these big companies. They come up with these ideas because their fundamentals are strong. They know they are transforms, and they will come up with an idea and sample it, experiment with it overnight. And next day, when you're in a meeting with them, they will tell you that their idea basically got you another couple of extra %. Which, by the way, for big companies like Apple, Google, Facebook, Netflix, or you name it, it's a big thing, right? Because look at the amount of users, right, for our devices or even Netflix. If you can do a task 2% better, multiply that with the number of people that the company serves. That's a big number. So yeah, hope this helps.
Okay. Now we'll take only 2 questions. First question
Sure.
is, which is the most straightforward approach for planning algorithm?
Not sure what you mean by planning algorithm.
I don't know, but the student has asked you, what is the most straightforward approach for planning algorithm?
I think we'll need a little more detail there. Because the person wants to follow up with me over email. You have my email. It's right here. Yeah, feel free to reach out and I can help you figure out your question.
Okay. Last question. Does Apple or any other company use artificial intelligence into software development like cycle to save time and money? Life cycle.
So, yes. Yeah. The software development life cycle.
Life cycle.
Yeah. Yes. And I can't go into too much detail, but I can definitely say that we do. And there are people working full-time trying to come up with these ideas to optimize our pipeline and our processes. Mostly because, like I said, right, if we can figure out how to do things better, it impacts not just things within the company, the processes that the engineers like me are working on. It doesn't just save our time; it also saves time for all these millions and billions of users around the globe, for all of these devices and the offerings that we have on board. Yeah, so to give you a very top level example, so if we want to figure out, and I think someone asked about Mac OS 11, by the way, it's 11, you mentioned 14. Mac OS or anything iOS, 14 is the one for the phone. If we are announcing one of these OSs, which we do every year, obviously it goes through a year, or in fact, in some cases more than a year of development and testing. And that's part of the Apple experience. We want to make sure that we walk the extra mile, not just in development, but also validating that we've got not just the 98% common cases right, but also the 2% corner cases right. And if you can test, your devices or your OS, with a wide range of cases, there's a great chance that once your product hits the hands of the end user, the consumer, it will work the way it should. Now, part of doing that is to figure out, the critical path in the pipeline where we can incorporate these advanced concepts that AI offers and try to figure out how we can best test these devices and hit all those, not just the 98% common cases, which is what most companies do. But like I said earlier, right, the last mile, the 2% in this case is the most difficult. Because coming up with ideas that hit the 2% is basically what some people do full time, and there's big brains behind it. So yeah, there are AI concepts used trying to figure out how they can imitate, how their devices would be used in the field. When I say the field, that's Apple code word for the devices in the hands of the consumer. So if we can figure out how these and mimic how these devices are used, maybe we can cover the 2% much more easier rather than covering basic if-else condition cases to test out our anything in our hardware software stack, of which we have lots, right from like I said, the drivers OS, the hardware now, you name it, even the apps that run on the OS, we own a lot of them. So yeah, AI is even there. And not just Apple. Yeah, all the big names are behind this, and they're trying to figure out how they can best leverage AI in their processes wherever they can.
Okay. Thank you,
Hello.
Aman.
Hello.
Any other question? Yes, sir.
Madam,
Please.
I just wanted to know from Aman that is there the possibility of having some sponsored project which we can take for BE students under your field?
Yes. So I actually looked up this thing, because I think that would be a great idea for people or students to get some nice industrial experience, because we have a wide range of things and we're just constantly expanding. Every year there's something new. Now the thing is, Apple as a company tends to it operates in its own silos. We operate at a different level of secrecy, and a lot of the things that we do are all under the wraps. In fact, even the intern programs that we have are very cherry picked and chosen in terms of what projects we can offer. So that is a big concern at Apple. So unless you're part of the company and there as a full-time employee and at a certain level, they do not talk about projects. So that is definitely a concern. So in my case, I can't do much. But that said, there are ways out. And what we can do is, if you got an idea, I can basically, help out in certain cases, and you can reach out to me, and I can probably give you some direction, some pointers as to how you can get from, point A to point B. So that's definitely possible. Also, given the
next week we are holding a webinar in which I am going to talk on the B projects. Okay, so that's why I was looking at some possibility like starting sponsor project. So not only from Apple, is it possible from your network, whichever companies you are aware about? Okay, so even that will be welcome for us.
Yes, in fact, the other companies actually do official programs where they, not only mentor people, but they let you have access to certain resources. For example, if you want to build an AI model that's pretty deep, basic models can be trained here and there, but deep models might need access to, hardcore GPUs. And the best, out there are typically what are needed. Specifically NVIDIA GPUs, for example, or the TPUs from Google is what the industry uses. So these companies actually have offerings, and I can probably point you to some online material. If you submit a request, they get back to you.
Things if you have any such information, can you post it to us?
Sure. Yeah, absolutely. Yeah.
You can send to me or Manirodha madam, anyone.
Sure, for sure.
Okay.
Yeah.
So that when I speak in the next week, next Friday, I will be able to give some references.
Yeah. Okay. So the only requirement
the students can approach.
Right. If you got some nice ideas and the students are willing to put in the effort and the homework that's needed to stitch an idea together from scratch, there are opportunities everywhere. That's how it works. But all you need is the effort and the motivation, the drive to get there. So I will send some pointers, and then you can obviously identify people who have some great ideas and take it from there.
Okay. Thank you very much. Thank you.
No worries.
Yeah. Thank you, Aman. For
No.
Hello.
No worries.
yeah. Thank you so much, Aman, for joining us and sparing your time, almost 1 hour plus. Hope our students have got some insights on how to shape up their future in AI or related domain. So thank you so much.
No, totally. The pressure was all mine, and hopefully this helped at least, so the idea I had behind this talk was just to plant a seed in people's minds that, hey, you got a lot of options available. If you have the drive, the desire to get somewhere, the world's your oyster. You can come up with ideas, and people have access to the internet. YouTube is available to everyone. So yeah, you can definitely make something out of your career, or do some interesting projects on the side. It's always possible.
Yeah.
Okay. So we thank our principal for giving permission for this webinar, and Ashwini ma'am, my faculty friends, for joining this webinar. Also students for posting lots of questions, and also the speaker Aman, because when I asked Aman, can you share your AI experience, especially for EXTC student, he said immediately okay. So thank you, Aman, and also the MCL team of Tadumashan Engineering College for making a beautiful brochure. And today Monica madam was there to control the screen and all. So thank you. I think you got that important point. Branch doesn't matter. If you have a will, you can join anywhere. Thank you all of you. And please fill up the feedback form. And if you don't get the certificate after the feedback form, please mail me so that I can do the necessary things. Thank you.
Thank you.
Bye.
The pleasure was all mine. See you guys.
Yeah, thank you, Aman. Yeah.
So I'm officially ending the session. Aman?
Yeah.
Bye.
Yes. Thank you.
Thank you,
Yeah.
Aman.
Thank you, Aman.
No worries. Thank you. Thanks for attending.
Yeah, it was